Hey, welcome back here. We're going to talk a little bit more chemistry here with this video over naming compounds. So this kind of gets us into Unit 6, Unit 5. We did the chemical bonding. We talked about, ionic and covalent bonds and, ionic compounds and molecular compounds that are made from, covalent bonded stuff. So this gets us into how do we name those compounds? So if we have those compounds, then how do we name them? If we can name them, if we see the name of a compound, then how do I write the formula for that compound? So what we're going to do is we're going to break this naming compounds up into 5 separate sections or 5 separate categories. It's really kind of 3 different areas. You got your molecular compounds, which are compounds that's made from stuff that's bonded together through covalent bonds, through sharing of electrons. And then you have your ionic compounds, is where ions are bonded together, so there's been a transfer of electrons. These things have become charged and they're attracted to each other because of that opposite charge. So these are all dealing with ionic bonds, ionic compounds. And then this third category here would be acids. So we have acids, we have a different nomenclature, which is the term we use for a naming system. So we have a different nomenclature, a different naming system for each of these guys. So we're going to take the molecular compounds, which remember that's just nonmetals bonded with nonmetals, right? We'll have a naming system for that. We'll do a video on that, and then we'll do a separate video on each of these, even though they're all kind of the same and they're dealing with ionic compounds. Here we're just going to do basic problems. With these, we're going to deal with what happens if you have a transition metal or a special metal. That is a metal that's in the D block or some of the metals that's in the P block. We have to use a slightly different naming system for that. So we'll talk about that, how to write those formulas, and how to write the names if you're given the formulas with transition metals. And then ionic compounds with polyatomic ions. So if there's a polyatomic ion in there, remember the polyatomic ions, I gave you 24 of them for you to know. There's a whole list. You still need to be working on those. You still need to be learning those so we can use them. Because the better I know my polyatomics, then the easier this is going to be anytime I end up with a polyatomic in any of this naming stuff. I don't have to go and look and find out and figure out what that is. I need to be able to recognize the polyatomics. And if I recognize the polyatomics and I know their name, then it allows me to just kind of fly on through and get through the naming part faster. So if there's a polyatomic ion, I have to recognize the ion, I have to know what it's called, and then that helps me when I go to name compounds that involve those polyatomic ions, which polyatomic ions will also be involved in acids sometimes as well. Okay, so still an ionic compound. Remember, ionic compounds were metals bonded with nonmetals, right? So this is just nonmetals and nonmetals with molecular. All of these guys will know it's an ionic compound because it's a metal bonded with a nonmetal. Or in the case of a polyatomic, it's a metal bonded with a polyatomic ion that is negatively charged. Or it could be a positively charged ionic compound bonded with a nonmetal. Or it could be a positively charged ionic compound or positively charged polyatomic with a negatively charged polyatomic. So there's different ways that it can be involved there, but in general, it's a positively charged something, which is usually a metal, right? And then a negatively charged something, which is usually a non-metal, or it could be a polyatomic, right? And then acids are hydrogen bonded with some nonmetals or hydrogen bonded with polyatomics. And we'll get into each of those individually. Real quick, I'll show you just a thing or two about an example of each of them, what they look like. So with all of these, we're going to go in both directions. If we're given the formula, we need to be able to write the name. And then if we're given the name, we need to be able to write the formula. So we'll be able to go both ways for this, okay? So an example of a molecular compound would be something we're super familiar with, just H2O, or water, right? So this is a nonmetal and a nonmetal. So we commonly refer to this as water, but technically this would be dihydrogen monoxide, monoxide, okay? You have 2 hydrogens, you have 1 oxide. So when it comes to molecular compounds, we'll be using those prefixes that you guys are familiar with, mono, di, tri, and so on and so on and so on and so on. Well, it continues to go, but we will not go past 10. So we'll go know the first 10, and then beyond that, we don't have to worry about that. You know, mono, di, tri, tetra, penta, and on and on and on and on. Okay, so I'll make sure that you have a list of that as well. So this is a molecular compound, and then eraser, excuse me. An ionic compound, a simple ionic compound that you guys would be familiar with would be NaCl. All right, I know this is an ionic compound because this is a metal and this is a non-metal. Okay, so these guys will be bonded by transferring of electrons. All right, making it ionic. Right, so this would be sodium chloride. Sodium chloride. It's basically just you name this and you name this, and you take the chlorine, we change the ending of chlorine to "ide," sodium chloride. No prefixes are involved with these ionic compounds. So with molecular compounds, we were using prefixes, the mono, di, tri, tetra, penta, hexa, yada, yada, yada. We're not doing that when it comes to the ionic compounds. All right, so an ionic compound with a special metal or a transition metal, an example of that would be something like this formula here. That's a U. All right, so this is a copper oxide, but copper can have multiple oxidation numbers. So this is the first time you've heard me use the term oxidation number. What is an oxidation number? And I'll go into a little more detail later on again, but an oxidation number is basically just the charge that an atom would have when it becomes the ion that it wants to become an ion. So in this compound, this guy has become an ion, right? So what is the charge of this metal in the ion? That is its oxidation number, okay? So this particular, a lot of elements just have one oxidation numbers. But these transition metals, many of your transmission metals or your special metals and your P block and your D block can have multiple oxidation numbers. So that's why we have to kind of think about them a little bit different. We have to name them a little bit different. So we know, okay, this is a copper oxide, but there's more than one copper oxide. Which one is this? And this one would actually just be a copper 1 oxide. So the number in there tells me which copper it is. Copper 1 oxide. I'll explain to you how I get the fact that it's a copper 1 oxide later on. But so this is it's very similar to this. The number itself, that's not necessarily a problem. We can have an ionic compound such as magnesium chloride. Just because there's a number there doesn't automatically mean it's a transition metal. This magnesium chloride would just be a basic ionic compound. It's not a transition metal. It's not a special metal. So just so there's a number there, that's not necessarily the problem. Okay. And then an ionic compound with polyatomic would be something like this. So we have aluminum, and then we can go nitrate. So we have to recognize that NO3 is a polyatomic. So I just named that polyatomic, that's nitrate, right? And it's bonded with aluminum. So we have aluminum nitrate. Aluminum is acting like the cation, it's positively charged. The cation, the positively charged thing, always goes first. And then the negatively charged thing, which is usually your nonmetal, can be your polyatomic in this case, right, goes last. So your cation and your anion are bonded together, right? Aluminum nitrate. Now, if you're wondering about the parentheses that we have here in this number 3, anytime I have a polyatomic ion, I have a group of atoms that are bonded together. They're together, and together they have a charge, so then they're bonding with aluminums. In this case, we need 3 of these guys to bond with 1 aluminum in order to make the whole compound neutral, right? So this number outside the parentheses here is telling me how many I have of the stuff inside the parentheses. So I have 1 N and 3 O's in a nitrate, okay? So 1 N and 3 O's make a nitrate, but then I have 3 of those. I have 3 nitrates, okay? And I only have 1 aluminum here, okay? So, and once again, we can have parentheses with these other guys involved here too. But a lot of times it's with a polyatomic. Okay. And then an example of an acid. I told you that an acid is just hydrogen bonded with a nonmetal. So this would be an acid. This would be hydrochloric acid, hydrogen bonded with the chlorine. I put the AQ here. The AQ just means aqueous, or it means that it's dissolved in water. Technically, if I can take this in gas form and it would just be a molecular compound, we would say that that is hydrogen monochloride, right? Or sometimes people just say hydrogen chloride. But as an acid, when it's dissolved in water, it becomes an acid. So this little AQ, aqueous, means it's dissolved in water. Lets us know that, hey, I'm dealing with an acid right here. So as an acid, we would name this hydrochloric acid. All right. And I can also have acids like this that are made from the polyatomic. So this would be the polyatomic SO4. Once again, I have to recognize it's a polyatomic. This is sulfate, okay? And then sulfate as an acid is going to make sulfuric acid, okay? So enough hydrogens to make this guy neutral, and that's the acid. Okay, so hydrogen bonded with a polyatomic, or hydrogen bonded with your halogens mainly, for a nonmetal makes an acid. All right, so there's just a little brief overview of what we're going to do, and I'll go in and explain how to do each of these 5 things in a separate video, and then you'll have some work to do with each of those. Okay.